Alright, welcome to this video on lesson 7.5 about hyperbolas. Let's just get to it. So at the beginning of class, we did a warm-up just like normal, and then we started on our exploration portion of the day. And what we did in class was we talked about hyperbolas, and to first talk about hyperbolas, what we did was we started out by talking about ellipses. And so what I had you do is I had you graph the ellipse x squared over 4 plus y squared over 9 equal to 1. Now you should remember that the general form of an ellipse is x minus h squared over a squared plus y minus k squared over b squared equal to 1. Now, that's if the ellipse is going left to right, because whichever is your a value, whichever value is bigger, comparing a and b squared, whichever one's bigger, that's the direction that it goes. So because a is underneath x, it goes left to right. If I switch it, so now I have x minus h squared over b squared plus y minus k squared over a squared equal to 1, then that means my bigger value is a squared instead of b squared. It still stays the same, but this time it goes with y. And so that means my direction is going to be up and down rather than left to right. So if we keep that in mind, we can automatically tell which direction the parabola x squared over 4 plus y squared over 9 equal to 1 is going to go. So because I have a 9 here and a 4 here, that means my parabola goes up and down. The next piece of information you want to remember is your h and your k values. Okay? Your h and your k values are your center. So whatever number you have subtracted from x, and whatever number is your x value for your center, whatever value you have subtracted from your y is your y value from for your center. Since we have no number subtracted from x squared and y squared, that means my center is at 0, 0, which makes it really easy to graph this. So let me go to another slide here. So we have x squared over 4 plus y squared over 9 equal to 1. I then told you to graph this ellipse, and I told you that obviously we know our center is 0, 0, and we use the 4 and the 9 to figure out which direction we go. So first off, I'm going to put my point at 0, 0. So there's my center of my ellipse. Now the 4, remember, is a squared. So that means my it should be b squared because that's smaller than 9. So my b value is going to be 2 because b squared is 4. That means I square root it and I get 2. Okay, so doing the same thing with 9, a squared is 9, which means a has to equal 3. So my b value is 2, my a value is 3. Now if you remember from an ellipse, when I graph an ellipse, the a value is the longer length. It relates to my major axis. And again, you can tell which direction you go because that 9 is under the y squared. So I'm going to go up from my center 3 units and put a new point. So let's say, here we go, right here, 3 units, 1, 2, 3, and I'm going to put a point there. There's one of my vertices. Now, because it's 3, I'm going to go up and down. So I go down 1, 2, 3. Okay, and then I put a point there as well. So that's my 2 vertices for this ellipse. Then I do my co-vertices. Those are the vertices going the opposite direction. So A goes up and down in this ellipse, and that means B is going to go left to right. So I'm going to go left to right 2 units. So I've got 2 units left and right. I put my co-vertices. So now that I have my co-vertices, what we're going to do is we're going to draw a box around these 4 vertices that connects each one of them. So here's my left side, here's my right side and bottom, and here's the top portion. So my ellipse goes inside this imaginary box that we can't see. Okay, so what I'm going to do next is I'm going to connect all 4 of my points on the edges of the box. So I curve it there, curve it there, curve it there, and curve it there. That looks a little better. So here's the graph of my ellipse. So this is what we did in class. The next thing I told you to do is to turn this negative. So I have x squared over 4 minus y squared over 9 equal to 1. From here, I instructed you that, well, I first showed you what the graph of any normal hyperbola is going to look like, but I used this as an example. So what I had you do is I had you draw in the diagonals of the box, which look kind of like that. And here's the other diagonal. Okay, so here are the 2 diagonals. From here, again, we're going to use the same fact that I have 4 and 9, but we've already got my box drawn. The 4 and the 9 help you draw your box. To find your center, you do the same thing as if you had an ellipse. The only difference is now you have that negative sign. Now the question is, which direction is this going to face? Is it going to go up and down, or is it going to go left and right? Well, the way you tell that is by the negative sign. Whichever value is negative, or what I should say is, whichever value is positive, that's the direction your hyperbola is going to face. So because my x squared is positive, that means my hyperbola is going left to right. So this hyperbola is going to left to right. So that's a little different than an ellipse. If you take an ellipse and you take the opposite sign of the inside of the middle, instead of plus you have minus, it's just going to go the opposite direction. So before our ellipse went up and down, now this hyperbola is going to go left to right. So when I graph this hyperbola, I start from my co-vertices this time. So the co-vertices are the vertices of my hyperbola. So from here, all you have to do is draw out your hyperbola toward these diagonals. And one thing you would have noticed in our investigation in class is the hyperbolas, even though I go out forever, because these lines and hyperbolas go out forever, they'll continue on forever and they will never touch these diagonals, these lines that we've drawn diagonally. They will get closer and closer, but they will never ever actually reach these lines. And that's one key property of a hyperbola. Alright, so that's kind of what we did in the exploration. What you probably would have wanted to think about when you were writing up about the exploration is what's going on with the relationship between the diagonals and the hyperbola, how it gets closer and closer but never touches. But also another thing would be is the distance from the hyperbola itself to the center is the same distance from the hyperbola to the focus. So somewhere out here we have 2 foci. So those 2 red points I just drew are my foci of my hyperbola. The distance from here to here is going to be the same as from here to here. So the distance from the focus to the vertex of the hyperbola will be the same distance as from the vertex to the hyperbola. So these will both be the same value. I'm going to use a different color because you can't really read that. So these are the same values. Alright, so that's kind of what we did in exploration. So let's move on to some extra piece of information here. Alright, so let's see here. One key piece of information is, again, the equation of a hyperbola is x minus h squared over a squared minus y minus k squared over b squared equal to 1. If you have it look like this, then your hyperbola is going to go left to right. If you have y minus k squared over a squared minus x minus h squared over b squared equal to 1, then it's going to go up and down. And the reason again for this is the y value is positive in the bottom example and x is positive in the top example. So that's really important that you know. A is the length of the major axis, again. Or excuse me, is half the major axis. And B is going to be half the minor axis. So nothing is different from a hyperbola to an ellipse in terms of the major and minor axis. Okay, so that's that. The next part of information that you need to know is when we drew our box, we draw our box from our A and our B values. So if we have our box like this, remember we drew our diagonals through the corners of the box. These diagonals have a special name. They're called asymptotes. Now I know what you're thinking, and yes, it sounds like the bad word, but I won't say that word because it's a bad word. So, and this is school. So, you know, laugh right now, get it out of your system. Go ahead. I'll give you time. Alright, that should be good. So, these two lines here are called asymptotes. Okay? And those two lines are basically the guidelines of the hyperbola. The hyperbola will never ever touch these lines. It's kind of like a guardrail on the road. You don't want to touch them because if you touch them, the car will get scratched up. Now, it does happen occasionally because, you know, we're human and we make mistakes. But when we're talking about hyperbolas will never ever touch the asymptotes of the hyperbola that you can't see. Now, the difference between a hyperbola and what we graph is the asymptotes in the box are not really a part of the graph. They are what we use to help us graph the hyperbola. And so you just have to remember when you're graphing hyperbola, that's your minor axis, that's your major axis, let's say, and these 2 points are your vertices. Okay, and you just have to remember that when you graph it, you just go along until you get closer and closer toward your asymptotes. Now, I don't really care if it looks perfect. All I really care about is that you graph the point where it's supposed to be for the vertice or the vertex, and that your hyperbola is going toward the asymptotes. Okay, so that's what's really important, is that when you graph this, your hyperbola goes toward your asymptotes. Okay, so those are asymptotes. Now to find the asymptote, you would have to, it's just like any other line. So sometimes the equation of the asymptote you would have to find. So we'd use y equals mx plus b. And b, if you remember from Algebra 1, is the y-intercept, where it crosses the y-axis, and m is your slope. This is really easy to find because you have a point here and you have a point here. So you know exactly what your 2 points are to help you find the slope. And then you just have to find out where it crosses the y-axis. You could also use point slope form, which is y minus y1 equal to m times x minus x1. And it's really easy to do again. You find the slope, choose one of the points, one of these 2 points here, and substitute it in for x1 and y1. And then solve for y, and then you get your equation for your asymptote. And you do the same thing for the asymptote that's going the other direction. Alright, so that's asymptotes. Let's see. We talked about the center. We talked about the major minor axis. We talked about the asymptotes. Now we talk about the focus. So if we have x minus h squared over a squared minus y minus k squared over b squared equal to 1, you got to think about which direction we're facing. Again, this one is going left to right, which means my foci are going to be on the left to right axis. So whichever direction I face going left to right, my foci will also be on that imaginary line that you don't have to draw. And so your foci are actually going to be, if you remember from here we go, from this diagram, let me just copy this real quick and bring it over. Okay, so here's the diagram of our older. I'm going to erase the ellipse on the inside so we can see, and I'm going to erase the asymptotes in the inside. So remember, the distance from my center to my vertex, which is right here, is going to be the same as the distance from the vertex to my focus. Okay, so if you remember, this distance was b, right? So you're going to go the same distance outside in both directions. So if my center was at 0, 0, then my vertex is going to be that much more past 0, 0. And remember, it's 2 units. So if we're at 0, 0 for my center, oops, my vertices, so this is my center, my vertices will be at plus or minus 2, 0. So this point here is positive 2, 0, and this point here is negative 2, 0. Okay? Now, the next thing we need to remember is, how do I get to my focus? Well, it's going to be the same distance. So I go another 2 units. So this point, my foci, is going to be at positive 4, right? That's another 2 units in the right direction. And this is going to be at negative 4, 0. So I have plus or minus 4, 0 as my foci. Now if you switch it so that you have a hyperbola going up and down, it's going to be the same process. But instead, you're just going to have, you're just going to add the distance from here to here instead. Let me change color. You're going to add this distance here and there. So whatever the distance from the center to the vertex is, will be the same from the vertex to the focus. So that's what you need to remember. So if we think of in terms of how to find it just given the equation, we start out with hk. If we're going left to right, I'm going to add to h. So I add and subtract my b value to my h. So this is for a left to right hyperbola. If I have hk for a up and down parabola, then I'm going to add and subtract from my k value. So this should be plus or minus a, because a is going the opposite direction, right? There you go. So that's how this works. that's how you find the focus. So let's do an example real quick. Okay, so let's say I have to find the coordinates of the foci of the hyperbola with the equation x squared over 16 minus y squared over 9 equal to 1. So again, our equation is going to be going left to right. Our hyperbola is going left to right. So my I got to find my a value. Since 16 is the biggest value, that's a squared. So that means a is going to be 4, because square root of 16 is 4. And 9 is square root of 9 is 3, so that means b is 3. Okay, so if I wanted to graph this to help me, that would be fine. So again, my center is 0, 0, because I'm not subtracting anything from x or y. So I'm going to go up, or go left to right 4 units. 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to go up 3. 1, 2, 3. 1, 2, 3. So those are my vertices and my co-vertices of my box. So I'll draw in my box. There we go. Right here. And then because this is a hyperbola going left to right, I have to go the same distance from the center to my vertices, which are the bigger of the 2 blue dots. So this length is 4 units. So that means I'm going to go 4 units even further. So we're at -4, 0 here. So I'm going to be, my focus is going to be at -8, 0. And I'm going to go 4 units in the opposite direction, which gives me +8, 0. So my 2 foci are going to be at ±8, 0. That's as easy as it gets. That's a really easy problem, but I think you guys get the idea. All right. For this problem, you'll notice when I graph this, I didn't actually have to graph the hyperbola itself. I just needed to define where the foci were. So that's your example problem, and here's your multiple choice and free response question. Pause the video here now. If you have any questions about how to do these problems, you can always check out the solutions video after you submit the form, or you can send me an email. Here's your free response. Have a wonderful weekend, and we will see you on Monday.